Okay, welcome to part 2 of slope and equations of lines. In this video, we're going to talk about graphing horizontal and vertical lines. We're also going to talk about handling general form of a line, and then we're going to talk about average rate of change at the end. So that was a frown, and I really didn't mean to frown. It's the light in my eyes. Okay, so we want to be able to graph horizontal and vertical lines. Sometimes we have students that know when they see the equation of a line, oh, it's going to be horizontal or vertical, x equals something or y equals something, but they can get confused as to which one it is. Okay, so one thing that you can remember this by is a horizontal or vertical line cross the axis that they name. At the point they name. Okay, so when I'm talking about the line x equals 2, it's going through the x-axis at the point 2. Well, that's pretty easy, okay, because I know it's either horizontal or vertical, and if it's on the x-axis, it'd be on this axis here. I can't really draw a line besides the axis, all right, through this point unless it's vertical. Okay, so we're going to graph these two lines, and notice that they are lines that are horizontal and vertical, but they're fractions. Okay, so I wanted to kind of discuss with you how to handle those fractions. Really, if you can get the line to be between the right integers, that's good enough for my class. Okay, so let's think about this. I'm looking for the line y equals negative 13 halves, which is the same as y equals negative 6 and 1 half. Okay, so go to my y-axis. Here's my y-axis, right? And I'm going to negative 6. Here's negative, let's see, 1, 2, 3, 4, 5, 6. And 1 half. So that's between negative 6 and negative 7. Let's go ahead and plot on the axis. And I know it's going to cross that axis there. So we know it's going to be this horizontal line. And every point on this line is going to have a y value of negative 6.5. Every point. Another way to remember which way is which. The other way that we could actually write this is f of x is equal to negative 6 and 1 half, because many of you know that f of x can also replace that y. How about this one? Graphing x equals 28 divided by 5. Okay, graphing x equals 28 divided by 5. Let's think about this. This is the same as, let's see, 5 goes into 28 5 times, and that would be 3 left over, so 5 3/5. Okay, so this is going to be between 5 and 6 on the x-axis. So let's go to the x-axis here, coming over to 1, 2, 3, 4, 5, between 5 and 6. 5 3/5. Okay, so somewhere kind of in the middle. It's a little bit to the right of halfway, and we want to pass through that point, which would have to go this way. And again, every point on this line is going to have an x value of 5 3/5. So with this question, we are being asked to find the slope and the y-intercept of the line whose equation is 3x plus 6y minus 12 is equal to 0. Okay, so 3x plus 6y minus 12 is equal to 0. So it's very easy to find the slope and the y-intercept if it's in the right form. We can put it in slope-intercept form to get that information. Right now, we're not in slope-intercept form. We're in general form or standard form or however you want to call it. Okay, so what we want to do is we want to transform this into slope-intercept form, which means solve for y and put the terms in the right order. So let's isolate the term that has the y in it. That means keep this here and move everything else to the other side. All right, so we're going to keep 6y on the left. 6y is equal to, if I push this 3x to the other side, it becomes negative 3x. And if I push the negative 12 to the other side, it becomes positive 12. Now I'm going to divide everything through by 6 and simplify. So this becomes y equals negative 3 over 6x, negative 1/2 x, plus 12 over 6, or plus 2. Okay, so what does this mean? I'm now in slope-intercept form. I can identify my slope. Slope is equal to negative 1/2, and my y-intercept, which is 2. This means it's going to cross my y-axis at 2, and it's going to have the slope of down 1 over 2 thing going on. Okay, for this next example, we're going to talk about finding x-intercepts and y-intercepts if we're given an equation. These techniques work with any equation, not just a linear equation, so they're really good to really know well. Okay, so let's think about a y-intercept for a second. So something that's on the y-axis. What can you tell me about, let's just pick this one, okay? What can you tell me about the coordinate of anything that's on the y-axis? This is going to be a coordinate of 0, 3, right? How about one down here? 0, negative 6. Or maybe here? 0, negative 10. What can you tell me about their coordinates? Coordinates all have an x value of 0. Okay, so that means that anything that's on the y-axis or any y-intercept is going to have an x value of 0. Good to know. What that tells us is I can find the y-intercept of any line if I set my x value equal to 0. I can find my y-intercept by setting my x equal to 0 and solving for y. Okay, likewise, if you think about your x-intercepts, all of these are going to have y values of 0. So I can find my x-intercept, or septs, in this case it's just going to be 1, by setting y equal to 0 and solving for x. Okay, and so if I want to graph using intercepts, I'm going to find these two intercepts and then just connect the dots. This is pretty easy. Okay, so let's use this example. 3x minus 2y minus 6 is equal to find my y-intercept, let's see, I put 0 in for x. Okay, so I'm going to put 0 in for x and solve for y. Well, anytime I put 0 in for x, that term just kind of disappears, right? So I have 2y minus 6 equals 0. Let's move that minus 6 to the other side. So 2y, negative 2y is equal to 6, and y is equal to negative 3. Okay, that means my y-intercept is at negative 3. Right, now I'm going to do the same thing for my x-intercept. My x-intercept is found by putting a 0 in for y and solving for x. So coming back to that original equation, 3x minus 2 times 0 minus 6 is equal to 0. So this whole thing disappears, right? And I've got 3x minus 6 equals 0. So let's push the negative 6 to the other side, making it positive, and x is going to equal 2. On my x-axis, I hit x equals 2. I've got 2 points. I have enough to sketch a line that goes through them. Okay. So notice I did not use slope here. I could have to sketch the line, but it said, what does it say? Graph using intercepts, which means I need to plot both intercepts and then just sketch the line through. All right, the last type of problem in this video is going to be utilizing that average rate of change formula. So we're given the task to find the average rate of change of this function. F of x is equal to x squared minus 2x. And I'm going from x1 equals 3 to x2 equals 6. Okay, so anytime you're given an average rate of change problem, you're going to be given a function, and then you're going to be given a couple of x values. So let's look at the formula and then find a strategy that's going to help us solve this problem. average rate of change formula is, let's see, A rock is equal to f of x2 minus f of x1 divided by x2 minus x1. Okay, so what do I know? If I'm looking at what I'm given x1 and x2. I know that they're 3 and 6. So what I'm going to do is come to my formula and substitute. Anytime I see an x1, I'm going to substitute in 3. And anytime I see an x2, I'm going to substitute in 6. Okay, so let's look at that. This would be f of 6 minus f of 3 divided by 6 minus 3. Okay, all right, so I'm getting closer. I can tell you what the denominator is right now, right? Okay, so what I need is f of 6. How do I find that? Well, that's where I come back to my function. Okay, and I'm going to find f of 6 by substituting 6 into my function. 6 squared minus 2 times 6 is going to give me f of 6. So this is going to be 36 minus 12, also known as 24. Okay, and I'm also going to do f of 3 because I need that one right here. F of 3 is equal to 3 squared minus 2 times 3. Okay, 3 squared is 9, minus 2 times 3 is 6, and that's going to be 3. So now I know f of 6 is 24. I'm going to replace that here. And I know f of 3 is equal to 3. I'm going to replace that here. So let's go ahead and look at that. F of 6 changes to 24. F of 3 changes to 3. And then I've got 6 minus 3. I think that's also known as 3. All right, so let's finish this up. We're really close. 24 minus 3, that's 21. Divided by 3, which we know is 7. So after all is said and done, the average rate of change of this function between these two x points or x coordinates is just 7. Okay, so follow this algorithm and you can find the average rate of change of any function between any two x values. See you next time.